Hi YouTube, this is Joe Calton with Calton Cutlery. You can find us on the web, caltoncutlery.com. Today's a pretty exciting video. I know I start off most of my videos with, hey, this is something really exciting, but hey, if it wasn't exciting, why show it to you, right? So, I just picked up a metal shear. Picked it up about probably at the beginning of this month, but I've actually been out of town on working on a big project most of this entire month, so I haven't been able to get into the shop and work, much less shoot videos. But anyway, so we're going to go over it right now. I bought, I buy all my steel in sheets as much as I can. This sheet right here is the reason that I got this this shear. And I think I must have cut the end off that had the sticker on it. But this is 15N20. I get this from Admiral Steel Supply. And this is, I want to say it's about 70 or 80 thousandths thick, something like that. We'll grab the mic here in a little bit. Mic it out, that way you know how thick it is. But this comes about another foot longer than this, in a sheet like that. And it's for making pattern welded steel or Damascus, depends on who you talk to, what name you want to call it. But anyway, so I figured I'd just buy the sheet of steel and then I could cut it up to size with the bandsaw or on the abrasive chop saw. Well, this stuff is not, it's not hard, but it sure ain't annealed either. So it strips the teeth off of my bandsaw blades, and that right there is about as far as I could get through it with the abrasive chop saw. 15N20 is supposed to be something like, set that down, supposed to be like 1075 only with 2% nickel. And so I think what's happening is that nickel is gumming up the abrasive saw. So this sheet of steel strips the teeth off my bandsaw blades, and then it gums up my abrasive chop saw. So about the only thing that I found would cut it would be, a cutoff disc on, an angle grinder. Those seemed to be thin enough that they'd wear away fast enough as you were cutting, so that the gumming up issue, the gumming up thing wasn't an issue. So I got to thinking about it, and I thought, well, maybe I can go ahead and buy it pre-sheared and everything. But then what would I do with the two sheets of it that I had? So thought about taking it down to the welding shop. They have a shear down there. I think they have a pretty big hydraulic shear. And then I got to looking on YouTube, of course, and I found out about these small little manually operated shears. Now this one right here, I got it from MSC, which used to be Enco. And actually, hang on that second. I'll go grab the catalog. Okay, so this will be pretty current prices. This is March 2017, and here is, does that look clear to you? No. That's the ad for the shear. I got the 12-inch model. It says it'll do 7/16 inch round stock, a piece of flat bar 2 3/4 inches wide by 1/4 inch thick, and plate that's 1/8 of an inch thick. And the normal cost for this one is $136, and at the time of this printing it was on sale for $119. Enco's or MSC's always throwing sales, so I ended up getting mine. I think it was a 20% off sale, so I think I got it for like $100. And then if you spent $200 or so, then you got free shipping. So I threw in some other stuff to bring it up to, $200. And, so this is, roughly $100. Now, since I went over and grabbed the catalog, I grabbed the mic here, and it is 67 thousandths inch thick stock. So I bought this whole shear pretty much just to be able to cut these sheets up into coupons that I can go ahead and layer up and weld and forge weld and make Damascus. But of course, any tool, the more uses you can find for it, the better. So I did a modification on this, and pretty much what I did was I added a piece of angle iron to the support side of it, which we'll go ahead and I got my cameraman today, my boy Vance. He's moving the camera around, but once we get done with this part right here, we'll put it on the floor and then get you a good view around so you can see everything. But I added an angle plate onto this so it'll support the material being cut more on this side. And really that's the only modification I've done to it so far. Most of the time it'll probably stay up here on this particular bench. I've just got a C-clamp on the rear foot, you know, to hold it in place. But even though I got it for steel, and I played around with it for 2 or 3 hours when it came in, and I chopped up some copper pipe and some of the 15N20, some 1095, tried some plexiglass. It didn't work all that well for that, but what it did work really good for is kydex for making neck knife sheaths. So we'll go ahead and cut this piece up. Usually when I cut kydex up, I generally use kydex for just my neck knife sheath. So I just need, you know, a piece this long right here to about there. So I make a mark down here, cut this piece off. Are we zoomed in? No. And then just go ahead and cut each one of these strips out. So that's the layout that I normally do. Now normally when I'm cutting this, I take a piece of I think 1.5 inch bar stock, clamp it up, scribe it with a utility knife, and then snap it off, and then repeat through that, which is a fairly quick way to do it, but this way is even faster. So what we're going to do there is line that mark up, and then this, since this part is overhanging, I can't really see where the blade's going to come down, so I'm just going to take a square. There's a spot in here that you can put it up next to the blade. Line it up there. Now these cuts don't have to be super precise, but you know, they just need to be close, because these are still going to get trimmed up to make sheaths out of. But that right there is way faster than the whole, you know, clamp up, cut a line, bend it back and forth until it breaks off. Now since it's short enough that it's short enough the whole thing will fit in there, I can just make my lines. And it does tend to want to shift a little bit during the cut, but like I said, for this application, you know, these pieces are a little bit oversized anyway, so so it'll work good. And we got 2 more cuts, and it'll be and it's just that fast to cut up. We've got 7 pieces of kydex now to turn into neck knife sheaths, and the quality of the cut is pretty good. I would say it's comparable to the whole you know, score and then bend and snap method, but it's way faster. So then, while this is mounted up here, I got this little piece of the 15N20. We'll just cut a couple of pieces off of it, so you can kind of gauge how much force it takes to get through that size of material mounted on a bench like this. Now this bench is mounted, or it's built pretty tall because I put my chest freezer underneath it. Most of my benches I like to be fairly tall anyway, because I like to work standing up. But that's how come this one's so much taller. If it was a little bit shorter for this shear, you'd get a lot better leverage. But anyway, it is what it is. So that's way back here where you have the most mechanical advantage. And then here you can get more body leverage even though you have less mechanical advantage or leverage. So it jumps quite a bit more, you know, the farther away from the pinch point you get. So anyhow, so now we'll go ahead and use this for what I bought it for. Like I said, I just have a C-clamp on the back. So we'll take that off. Now this thing does weigh, what did it say? 59 pounds. So it's a pretty substantial piece of equipment for what it is. Okay, let me have the camera and I'll move it around while I'm talking. Alright, so that right there is that plate that I put on it. And all it is a piece of 3-inch angle iron. And then I drilled some holes in it to go use the bolts that came with it. Now these bolts go through the body and then thread into the blade on the back side. And then there's a couple of adjustment screws, Allen heads, to be able to adjust you know, the position of the blade. So that's all that is. I mean, I suppose I should probably go back and get a little bit longer of these bolts, but I haven't yet. It's got a nice hold down here that's adjustable for height. It doesn't look like it rotates back and forth. The frame here is made out of, probably 7/8 inch thick. I'm guessing it's cast iron, but it could be steel. We've got a nice lever that's, about 3 foot long. And then on this side, there's the blade, the thing with the 4 holes in it. And then the interesting part is that part of the frame right there. Let's lay it down so that you can... Okay, this is not at a 90 degree. There's a angle cut in here. So that way, as you're cutting material, as it bends down from the shearing process, you know, you can keep cutting. So this is the 12-inch wide version, and you can make longer than, or you can cut longer than 12-inch wide. So anyhow, so there's the shear and the piece of angle that I put on it. One nice thing about that angle is I was sitting here trying to figure out how to get this thing mounted on the floor. You know, to where I could cut big sheets of steel or bigger sheets of steel, you know, and then have tons of mechanical advantage. So I may end up putting a longer lever on this for these real wide sheets of steel. Might not, I'm not sure. So I thought about welding a plate to the feet and then putting a heavy weight on the back, and came up with a whole bunch of ideas. And then all of a sudden I thought, wait a minute, I've got this nice piece of angle here. That should be a pretty good place for a wedge. So I grabbed a 2x4, cut a chunk out of the end of it. Now that 2x4 will slip in. There's a ledge right here on the base of my power hammer. Now this power hammer weighs 1,300 pounds, and it's bolted to the shop floor, so it's not really going to go anywhere. But you take that 2x4, chuck that thing in there, and as long as you put force this way in the direction that the handle is going to be moving to make your cuts, there's no movement. Well, there's a little bit of wiggle, but not a whole lot, and it's pretty steady. And there's a little bit back and forth, but none where you're going to make your cut. So let's go ahead and cut some of this 15 and 20. Tape measure. Okay, so I said it's about 70 thousandths thick. It's 8 inches wide. And my coupons, I would like them to be about 4 inches long and I think that's inch and a quarter, maybe inch and a half. Inch and a half wide. Grab another 2x4 to act kind of like a table there. Now remember, this stuff so far has been a real bear to cut. It strips the teeth off my bandsaw blades and it gums up the wheel on my abrasive chop saw. I got it lined up. I got this, the hold down kind of screwed down to hold it in place. And it cuts it off just that easy. You could tell I was a little bit off by, probably 10 thousandths at the end of my cut. But, you know, this is going to get all stacked up, MIG together, and then forge welded, so there'll be plenty of waste to take care of that anyway. Get the cut started. And with this being on the floor, it's really nice because I can lean back into this, use an awful lot more body weight and less arm strength. And really get nice controlled cuts. I have tried cutting a little bit of a curve on this, and honestly it doesn't really like cutting curves. You can cut a slight curve in something that's fairly thin, but it's not very precise. In fact, now we're going to use the hold down for this one, since there's so small of amount of material to hold on to. And that one moved a bit. And there you go. Now we got 5 pieces ready to go ahead and stack them up with some 1095. And then start making some Damascus, and then one little piece. Not sure, I'm probably going to end up changing my measurements so that I don't have this amount of scrap, or I may use this little piece of scrap for, I don't know, pocket knives, or, you know, wood carving, whittling knives, you know, whatever. But anyway, so that's on that thin stuff. This is what I bought the shear for. But just to show a little bit more, this is a sheet of cold rolled 1095 high carbon steel. This has been annealed, and it's fairly easy to cut with the bandsaw. In fact, that's how I normally cut it with a bandsaw. But I just wanted to see, you know, this is a fairly wide piece of material. You know, it's 24 inches wide, whereas the shear will only cut a 12-inch wide cut. So we'll go ahead and cut this up. So I got my mark lined up back here. I'll use my square. Wow, I hit that right on. We'll go ahead and clamp this down. So it's clamped. Double check that it hasn't moved, which it hasn't. Now this steel will it will bend. The offside will have more of a bend to it than the 15N20 because this is softer material. You can see on this side right here how far down, because the body of the plate is still, you know, even with the table. So this shows you how far it moves down. And you can kind of see back there how it's going to miss the frame. This also seems pretty tough to correct. So like right here, I followed that line pretty good, but I'm off about 20 thousandths of an inch. I've cut to the left of my line. And this doesn't really want to make a curved cut, so it's going to be off farther when we get down here. So we'll go ahead and cut a little bit farther on this side. And then I think we'll just feed it all the way through. The last time I did this, I just turned the sheet, you know, flip the whole sheet over and then cut from the other side. But this time we'll do it this way. And like I said, this is 330 seconds. 330 seconds or 0.93 thick steel. And you can see how far off I was on that cut. And then this piece I cut it wrong on the other side also. It was the first cut I made, but in this, like I said, it's got, okay, back up some so you can see it's got quite a bit of movement from the plate going down. But that's okay, because what I'll do is I'll go ahead and cut all these up, probably trim the ends so that they're fairly even, and then just hammer, you know, straighten them out on the anvil. And then by the time I get them all welded up, everything, you know, it'll all work out anyways. But anyway, so for $100 now I've got a shear that will cut, well, $100 plus I think $5 worth of that angle iron, and some time to mount that plate to it. But I've got a shear that will cut that 15N20 for me real nice, so I don't have to have it sheared every time, and shear it to whatever size that I need. It also seems to work really good on kydex, and then I also tried it out on some copper, brass, and nickel silver for making mokumae, and boy, it cut, you know, goes through that stuff real easy also. And it's a portable machine, bench or floor mount, and it works really good. So like I said, let's see, where's the, so it's at MSC. How much time do we have there? MSC, the old enco. I don't have their website, but there it is. mscdirect.com. A 12-inch shear for $100 slices this stuff up that I couldn't cut any other way. Real easy, plus it cuts the kydex, and the non-ferrous metal's pretty good for mokumae also. It's a heck of a deal. So if you need a shear, this one seems to be working out pretty good. Hope you enjoyed the video, and we'll see you next time.